Hello everyone, welcome to my new video. Today we are going to start exercise 9.1 first question. So in our previous video we have discussed all the congruency rule. Now we have to do the questions. So first question is saying in quadrilateral ACBD. This is the quadrilateral where AC and AD. This AD and AC are equal and AB bisects angle A. And this line AB bisect this angle, means bisect means divide into two equal angles. Okay, we have to show that triangle ABC is congruent to triangle ABD, means this triangle is congruent to this triangle. And we have to say what can you say about BC and BD. We have to tell the relationship between BC and BD. Okay, so first we will prove this. So I am solving here, you can write in your notebook. I am writing the solution. In triangle ABC and triangle ABD. Okay, what is given? AC is equal to AD. AC is equal to AD, it is given, and AB bisects angle A. It divides angle A into two parts, one this angle and second this angle. So angle CAB is equal to angle BAD. This angle CAB angle is equal to BAD angle. Okay, and as given AB is common in both AB. So AB is equal to AB. 1 second. This is common. We have to write the reasons also. For these two reasons will be given in the question. Okay, now we can say that by what is this? This is side angle side. Side angle side, side angle side. That means by SAS, side angle side congruency rule. By side angle side congruency rule, triangle ABC is congruent to triangle ABD. Okay, this we have to show in the question. We have shown it here. Okay, now it is saying what can you say about BC and BD. So when we prove any two triangles congruent, that means their all sides are equal to each other. That means BC is the side of this triangle ABC and BD is of this triangle ABD. Here you can see BC and BD. They are on B on second number, here also second number, C on third number, here also third number. Means these are equal to each other. This is equal to this and this is equal to D. Okay, so by CPCT, this will be very much used in this chapter. By CPCT, BC is equal to BD. Okay, CPCT is meant by that all given sides are equal to each other. Okay, so this question is over. Now I am moving towards the next question. You can write this question. Now we are moving towards our second question, that is saying ABCD is a quadrilateral. First of all, if you can't see the diagram and this question, then you can open your book, exercise 9.1 second question. ABCD is a quadrilateral in which AD is equal to BC. This AD line is equal to BC and angle DAB is equal to angle CBA and angle DAB, this angle is equal to this angle. Prove that triangle ABD is congruent to triangle BAC. This triangle is congruent to this triangle. Okay, we have to prove this. So I am writing the solution. You can write in your notebook. solution. In triangle ABD and one second, and triangle BAC, what we can see, it is given that AD is equal to BC. So we can say AD is equal to BC, and it is given that angle DAB is equal to angle CBA. This angle is equal to this angle. So we can say that angle DAB is equal to angle CBA. Okay. So you can see that AB is common in both triangles. This triangle also AB is there, and this triangle also AB is there. So we can say AB, here AB it is BA, AB or BA both are here common. Okay. And these two given, in given we can say. Okay. So what do you see? Side angle side means side angle side angle side. So by side angle side, congruency rule, triangle ABD is congruent to triangle BAC. Okay, this we have proved. The first one is proved. Okay, now it is saying BD is equal to AC. How we can prove this? Can you see? BD is equal to AC. B is equal to A and D is equal to C, and both are equal to each other. That means BD is equal to CD. So in our previous question also we have used by CPCT. We can say that BD is equal to AC. This also proved. The second part is also done. Now look at the third part. Angle ABD is equal to angle BAC. Means angle ABD, this angle is equal to angle BAC. This angle. How to prove this? So for this we need nothing. We just need by CPCT. How? Because here it is angle ABD is equal to angle BAC. So ABD BAC means angle ABD is equal to angle BAC. So we can write by CPCT angle ABD is equal to angle BAC. Okay. So we have proved this also. So I am writing hence proved HP. Okay. So the second question is also done. So you can write in your notebook. Now we are going to do third question. Third question is saying AD and BC are equal perpendiculars to a line segment AB. So this is a line segment AB. So there are two perpendiculars equal to the line, that is AD and BC. AD and BC are perpendiculars to the line. That the angle is 90 degree. Okay. Here also. Show that CD bisects AB. We have to show that this line CD bisects this line. Bisect means like this is point O. So here OC is equal to OD. We have to prove that. Bisects means divide into two equal parts. Okay. So solution. First we will write what is given. Here what is given? AD is equal to BC. Perpendiculars means angle A is equal to angle B. Okay, this is given. What to find? To prove. What we have to prove? We have to prove that CD bisects AB. That is OC is equal to OD. OC is equal to OD. This we have to prove. Now proof. We have to find the proof. Okay. So for this OC and OD is equal to prove this, we have to congruent these two triangles. AOD this triangle and BOC this triangle. This triangle and this triangle we have to make congruent. By CPCD then we can prove this. So firstly we will prove these congruent. So in triangle AOD and triangle BOC. Okay, this angle is equal, angle A is equal to angle B and AD is equal to BC. Both are given in the question. Now what we can find the third one? As we know there are five properties, five congruency rule, that is side angle side, angle side angle, angle side, and side and RHS. So angle side angle, we need one angle. So I will say this angle X and this angle Y. So both are equal. Now you will ask how it is equal. These are two vertically opposite angle as you can see in the figure. Okay. So angle X is equal to, no, firstly we will write angle Y because here it is angle AOD, triangle AOD. Angle Y is equal to angle X. We will write vertically opposite angle. Vertical opposite angle. Okay. So see side angle side. So we will write here by angle side angle congruency rule. Triangle AOD is congruent to triangle BOC. This we have proved. Okay, but we have to find CD bisects AB, that is OC is equal to OD. Here you can see OC, OD. Here O is equal to here O and D is equal to C. That means by CPCT we can say that OC is equal to OD. Okay, HP means hence proved. You can at the last line you can write therefore CD bisects AB. Okay, so we have proved that CD bisects AB in this question, third question. So third question is also completed. Now write down in your notebook and write the next question. Okay. So now we are going to do the fourth question. So fourth question is saying L and M are two parallel lines. Here this L line and this M line is parallel to each other, intersected by another pair of parallel lines. Another pair of parallel lines is P and Q. It is given that P and Q is also parallel and L and M are also parallel and they are intersected with each other. Show that triangle ABC, this triangle ABC is congruent to triangle CDA. We have to prove these two triangles are congruent to each other. Okay, so I am going to solve the question. You can write in your notebook. So firstly we will write what is given in the question. Given is L is parallel to M and P is parallel to Q. This is given in the question. What we have to prove? We are writing to prove. To prove, we have to prove that triangle ABC is congruent to triangle CDA. Okay, this we have to prove. Now we are coming on the proof. Okay, so firstly you can see in triangle ABC and triangle CDA, what we can say that these two triangles are parallel, congruent. So firstly we can say angle, which angle? Angle BCA. This angle will be equal to this angle. Why? because these are two parallel lines, this is intersecting them, so these are alternate interior angle. So we can write that angle BCA is equal to angle DAC. Why? Because alternate interior angle. Okay, this is alternate interior angle. I have written in the short form. Okay, so you can understand this. Now second thing, you can see both the triangles have one common side, that is AC. This is common in both AC or CA. So we can write here AC is equal to CA or AC. These are two common sides. This is only one and common in both the triangles. Okay, I hope these two are clear to you. Now third one, what we can say? We can say angle PAC. This angle is equal to angle DCA. This angle. How? These L and M are parallel lines. It is given in the question. And this line intersecting AC is intersecting L and M. So these are alternate interior angle. This also alternate interior angle, and these two also alternate interior angle. So we can say that angle BAC. Angle BAC is equal to angle DCA. Why? Alternate interior angles. Okay, so you can see this is angle, side, angle. Firstly this angle, then side, then angle. Side, angle, side. Angle, side, angle. 1 second. So this is angle, side, angle congruency rule. So we can write by angle, side, angle congruency. What we can say? We can say that triangle ABC is congruent to triangle CDA. Triangle ABC is congruent to triangle CDA. Okay, this we have proved. You can write at last HP I am writing, hence proved. Okay, so the fourth question is also done. You can write this. I am giving time to write this. So now we are moving towards our fifth question of this exercise. So fifth question is saying line L is the bisector. Firstly, line L is given. Okay, here you can see in the figure and in your book also. Is the bisector of an angle, angle A. So line L is the bisector of angle A. This angle is A. The bisector of an angle means it divides into two equal angles. Okay, so this line divides angle A into two equal angles. Okay, so B is any point on L. B is any point on, we can let any point on L. BP and BQ are perpendiculars from the B. 1 second, here P and Q are not given. BP and BQ. So BP and BQ are perpendiculars from B to the arms of A, angle A. Angle A have these two arms. Here both are perpendicular from B. Means that is also 90 degree and this is also 90 degree. So we have to show that, means we have to prove two things here. First, triangle APB is congruent to triangle AQB. Means triangle APB, this triangle is congruent to this triangle, and BP is equal to BQ. These two lines BP and BQ perpendiculars are equal, that we have to show in this question. So firstly we will prove this and then this. So I am solving this. You can write in your notebook. Firstly we will write what is given in the question. In question it is given BP and BQ are perpendiculars. BP and BQ are perpendiculars. We can write perpendiculars like this. This is the symbol of perpendicular. And one more thing is given, line L is the angle bisector of angle A. So this divides it into two equal angles. So we can write angle PAB. Angle PAB is equal to angle QAB. Okay. This angle, this half angle is equal to this angle. The blue I marked that two angles are equal. Why? Because line L is angle bisector of A. Okay, this is the angle bisector. So what we have to prove? I am writing to prove. What we have to prove? So firstly these two, first and second, you can write here. I am writing only first and second. Okay, so now I am proving this. Proof. One thing I want to tell in common in all question, in geometry question like triangle, circle, quadrilaterals, if you don't know anything, then also you can write given, to prove and prove. Then you can think about it. Don't directly solve the question. Firstly write what is given in the language and what we have to prove, then you come on proof. Okay, so now I am proving it. In triangle APB and triangle AQB, what we can find similar? Firstly we have proved this, so we can write angle PAB is equal to angle QAB. Okay, from here we can write this reason, same here also. Okay, then what? These are perpendicular, BP and BQ. So the perpendiculars are of 90 degree. So we can write angle BPA is equal to angle BQA. Why? Because both 90 degree. Okay, then here you can see one side is common, AB and BA. AB here also and AB here also. It is common side. So we can write AB is equal to AB. Why? Because it is common. Okay, so by angle side, congruency rule, angle side congruency rule, we can say that APB is congruent to AQB. You can write here APB is congruent to AQB. This is done. We have proved this. Now how we can prove BP is equal to BQ? We can say by CPCT. CPCT means if we prove any two triangles congruent, then their similar sides will be equal to each other and all angles will be equal. Okay, so by CPCT we can say that BP is equal to BQ. BP is equal to BQ. Okay, this we have proved. We have proved the first part also and second part also. So you can write this in your notebook. The fifth question is over. After this I am going to do the sixth question. So now we are going to do the sixth question. So the sixth question is saying, in figure 7.21, this figure is given. This is a rough figure. You can see accurate figure in your book. Here it is given AC is equal to AE. This AC is equal to AE, these two dots, and AB is equal to AD. This AB is equal to AD. Okay, and angle BAD, this angle is equal to angle EAC, this angle EAC. We have to show that BC is equal to DE, means this BC is equal to full ED. Okay, so I am solving this. You can write in your notebook. So firstly, I have tell you in the previous question also that we have to write firstly what? Given. What is given? So I am writing here given. What it is given? AC is equal to AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. Don't think that this is written in the question why we should write it. You have to write, then you will get marks. So what we have to prove? I am writing here to prove. To prove what? BC is equal to DE. BC is equal to DE. This we have to prove. So now we come on the proof. So we know that angle BAD is equal to angle EAC. Angle BAD is equal to angle EAC. 1 second. This we know. So for this BC and ED, we have to prove two triangles congruent. What triangles? First we have to prove triangle ABC and triangle EAD. So we have to prove these two angles equal. What two angles we have to prove? This one and this one. These two angles with blue, this line is given, this angle and this angle we have to prove equal. Okay, what is this? BAC angle is equal to EAC angle. Okay, it is EAC is given, we have to find EAD angle. Okay, how we can do this? If we add this angle, angle DAC, if we add this much angle in both these, so we will get these two angles. I am understanding that you can't understand this, but try. Angle BAD plus angle DAC is equal to angle EAC plus angle DAC. Okay, both we are adding DAC. So BAD plus DAC, BAD plus DAC. So this is this angle plus this angle will be full this angle. So it will be angle BAC is equal to what angle? Here EAC, we know EAC, we have EAC plus this DAC will be EAD, angle EAD. So we will letting this as first. Okay, so now we have to prove these two triangle congruent. Okay, so I am proving it congruent in triangle ABC and triangle and what triangle? EAD. Okay, what we know that we have to prove it. So it is given already. This we have find here this. So it will be side angle side. Okay, so we can say that AC is equal to AE, this we know, and angle BAC is equal to angle EAC, and this is also given AB is equal to AD. AB is equal to AD. So these two are given and this we are finding from first. Okay, so by side angle side congruency rule, we can say that these two angles, this and this angle, are congruent. Okay, you can write here. Okay, so we have proved these two triangle as congruent. Now we have to find BC is equal to DE. So simply we can write by CPCT we can prove that BC is equal to DE by CPCT. Okay, you have to write here by CPCT BC is equal to DE. So our this question is also over. These are easy question, but we have to do some, we have to add or subtract, then we can find the congruent angle. congruent triangle, sorry. Okay, so this is done. You have to write this. Now we are going to do the seventh question. So the seventh question is saying AB is a line segment. Here you can see AB is a line segment and P is the midpoint of AB. P is the midpoint of AB. So by this line we can say P divided into two equal line segments, that is AP and PB, that we will discuss later, and D and E are the points on the same side of AB. See, D and E are the points. B from B there is E and from A there is D. Okay, such that angle BAD is equal to angle ABA, ABE. So angle BAD, this angle is equal to angle ABE. So these two angles are equal, and angle EPA is equal to angle DPB, means this angle DPB is equal to angle EPA. These two angles are also equal. So this is the figure. We have to show that triangle DAP is congruent to triangle EBP, means EBP, this triangle is congruent to this triangle. Okay, so now I am solving this. You can write in your notebook. So we have to solve the first part. So how we can solve? We can make it congruent. Firstly, we can make this angle angle EPB, this full angle EPB is equal to angle this full angle till here. Okay, but it is given only this and this angle are equal. The middle part is common in both the sides, both the angles. Okay, so can we add this angle? Can we add DPE, angle DPE to both this? Then we can find this also. Okay, so I am adding that. So firstly, one second, what can I write? First we have to write what is given in the question. Okay, given is angle BAD is equal to angle ABE, and one more thing is given, angle EPA is equal to angle DPP. Okay, now what we have to prove, that is to prove first part and second part. You can copy this fully. Okay, now proof. So firstly we can say that angle EPA, this angle is equal to this angle EPA is equal to angle DPP. Okay, this we know. We have to add angle DPE, add angle DPE to both side of this expression. Okay, so angle EPA plus angle DPE is equal to angle DPB plus angle DPE. So see, angle EPA plus DPE, EPA plus DPA, so this will be fully this angle DPA. So it will be angle DPA is equal to angle here EPB, here fully EPB. Okay, angle EPB, this we let as A. Okay. So I am taking this angle. Okay, we this triangle, these two triangle I am taking. So I can write in triangle DAP and triangle EBP. Okay, firstly we take this angle. So angle BAD is equal to angle ABE. Okay, it is given in the question. Okay, then we know that AB is the line segment and P is the midpoint. So P is the midpoint. So midpoint divides it into two equal. So we can write AP is equal to PB. P is midpoint. We have to write the reason also. Okay, P is the midpoint. Then we have find this angle DPA is equal to angle EBP from A. Okay, so you can see here angle, side, angle. Firstly this angle, then side, then angle. By angle, side angle. By angle, side angle congruency rule, we can say that these two triangles are congruent. You can write here triangle DAP is congruent to triangle EBP like this. So first part is proved. Now second part is saying AD is equal to BE, means this long line AD is equal to BE. How we can prove this? We have proved that two triangles are congruent. Here we have proved that. Okay, so by CPCT we can also prove that this is also equal. So you can write here by CPCT AD is equal to BE. Okay, this also proved. And at last you can write hence proved. We have proved all the two parts. So this question is over. In triangle chapter every question is of only congruency rule. So you must learn the 5 congruency rules that I have told in the first video, and we have to add or subtract some angle, then we will get the proper angle that is needed for the congruency rule. Okay, so this question is also over. Now you can write this in your notebook. So now we are moving towards our last question of exercise 7.1. So this is the 8th question. This question is having 4 parts. But first we will solve first, then I will erase, then second, like this we will do. Here it is not clearly visible, you can see in your notebook. So 8th question is saying in right triangle ABC. Here this figure ABC is a right triangle and right angle at C. This means right angle at C means angle C is 90 degree. ABC. This is right angle at C. Okay. M is the midpoint of the hypotenuse AB. This M is the midpoint. That means MB is equal to MA. Okay. C is joined to M and produced to a point D. C is joined to M and is produced till D, such that DM is equal to CM. Means DM is equal to CM. That means M is the midpoint of DC also. CD also M is the midpoint. Point D is joined to point B. Show that this is joined to this point. What we have to show? First part is saying triangle AMC is congruent to triangle BMD. Okay, so triangle AMC, this triangle is congruent to this triangle BMD. Okay, so how we can prove this? So I am going to solve this. You can write in your notebook. Okay, so firstly solution. In triangle AMC and triangle BMD. Okay, what we can see common? Here it is given DM is equal to CM. Okay, so we will write DM is equal to CM. CM is equal to DM. It is given in the question. And you can see this angle BDMB and angle CMA. These are vertically opposite angle. So we can write angle DMB is equal to angle CMA. Vertically opposite angle. I am writing in short form. You can write fully vertically opposite angle. Now side is there, angle is there. If we prove this side also, AM is equal to MB. Here you know M is the midpoint of hypotenuse AB. So we can write that AM is equal to BM. How? 1 second. AM is equal to BM. How? M is the midpoint. Is midpoint. Okay. So by side angle side. Here we will write by side angle side congruency. We can say that triangle AMC is congruent to triangle BMT. Okay, so this we have proved. The first part of this question is proved. Now we are going towards the second part. Okay, you can write this. I am writing second part here only because there is a space. Second part is saying angle DBC is a right angle. We have to prove that angle DBC, this angle is a right angle. How we can prove that? So firstly, what we can do, we can use this. How we prove congruent, we can use this by CPCT. By CPCT of triangle this and this. Can we prove that AC is equal to BD? AC is equal to BD. Can we prove that? Because these two triangles are congruent. AC and BD. First, third and first, third. That means we can say that by CPCT. So AC is equal to BD. Okay. So these are corresponding sides. Okay. So we can, if they are corresponding side, then we can also say AC is parallel to BD. Okay, we can also say AC is parallel to BD, and you can see in the figure also. Now we have to prove that this angle is 90 degree. How we can prove that? As we know that ABC is a right angle. Right angle at C. We know that angle C is 90 degree. Okay, and angle B and angle C are co-interior angles. So we have studied in the properties of parallel lines and intersecting line, co-interior, sum of co-interior angle is 180 degree. So we can write that angle B plus angle C is equal to 180 degree. Right here co-interior angle. Okay. So we know that angle C is 90 degree, right angle at C. So angle B plus 90 degree is equal to 180 degree. So angle B is equal to, here you can see 90 will go here, so 180 minus 90. So value of angle B is also 180 minus 90 will be 90 only. So angle B is equal to 90. That means angle DBC is equal to 90 degree. Okay, so this is also proved. The second part is also proved. Both the parts we have proved of this question. Now two more parts are left. I am erasing this, then I will write that. Okay, you can write this now. So now we are going to do the third and fourth part of 8th question. So the third part is saying triangle DBC is congruent to triangle ACB. We have to prove this DBC triangle is congruent to ACB triangle. Okay. So I am going to solve this. You can write in your notebook. Third part. In triangle DBC and triangle ACB. So firstly, what can we see? We know that BD is equal to CA. BD is equal to CA. Proved in second question. We have proved earlier. So here you can write proved in second part. Okay. Now So as we know that DBA, angle DBA is equal to angle ACB, both 90 degree. This also we have proved in the second part. Now you can see here BC and BC. BC and CB are common here. Okay, so we can write BC is equal to CB common. One second. Common. Okay, so by SAS, side angle side congruency, we can say that triangle DBC is congruent to triangle ACB. Okay, this we have proved. Third part is over. Now we are going to do the fourth part. Fourth part is saying CM is equal to half of AB. This CM line is equal to half of AB. So firstly we have done this DBC and ACB. So we can prove that DC is equal to AB. AB is equal to CD. AB is equal to CD. DC is equal to AB. Okay. So by CPCT we can say that what we can say DC is equal to AB. Okay, DC is equal to AB. Now we have to prove that CM is half of that AB. So how we can say CM is half of AB means CM is equal to AM. Okay, so as we know M is the midpoint of both. DC is equal to AB, so half of DC is equal to half of AB. So half of DC is CM is equal to half of AB. Okay, so we have proved this also. The second part is also proved here. We have to both sides we have to do the half and we will get by CPCT we have done that DC is equal to AB, then half, then CM is equal to half of AB. Okay, so both the parts are done. 8th question is also done, and our exercise 7.1, this is the last question, this is also done. So thank you for watching my video, and don't forget to subscribe my channel and share it to your friends. And in our next video we will start the exercise 7.2. Okay, thank you.